Objective 3. Compute and interpret the linear correlation coefficient. In practice, linear correlation coefficients are found using technology. However, we will present one computation by hand so that you might gain an appreciation as to how the formula measures the strength of the linear relation. Example, we're going to computing the correlation coefficient by hand. So for the data below that's shown here, we want to compute the linear correlation coefficient. First thing we need to do is we need to create a scatter diagram to observe the association between the variables. So let's go ahead and do that. So I'm going to open up StatCrunch, okay, and our first variable is x. We're going to put in our values 1, 3, 3, 6, and then 7. And then we have our y. We have 18, 13, 9, 6, and then 4. And what we want to do is we want to create a scatter diagram. So we're going to go to Graph and select Scatter Plot. We have our x variable as x. We have our y variable as y. Okay. And then we want to make sure that we have a display of point. Okay, and then what we're going to do is now we're going to go ahead and then create the scatter plot. So let's see what happens with the scatter plot. Okay, so there is our scatter plot. I'm going to go ahead and copy that. So if you take a look at that, okay, so there is our scatter plot. Okay, so here's our scatter plot, and if you notice here, we can see what's going on with our points. Okay, now the next thing we want to do is in step 1 we need to compute the sample mean, the standard deviation for the x values, the sample mean for y, and the sample mean for the response variables of y. So what we can do is we can go ahead and do that by using StatCrunch. So what we can do is we're going to go to Stat, we're going to go to Summary Stats, we're going to select Columns, we're going to select both of them. Okay, and then what do we want? Well, we want the mean and we want the standard deviation. Okay, so we're going to select Compute. So now we're going to go ahead and select Compute. And then we're going to determine what our mean is. So if you take a look here, the sample mean for x is 4. The sample mean for y is 10. So I want you to notice here that what we would do is then we would create a vertical line. So a vertical line that's going to go through 4 that represents the mean for the x variables, and then for 10 is going to represent the sample mean for y. So I have that graph completed here, so I want to go ahead and delete that. And then from here you can see the graph now. So here's the sample mean for y, here's the sample mean for x. Okay, so that's the first step. So the first step down here, as you can see, is the following. So from table 2, we can see that the sample mean is 4. So let's go ahead and highlight that. So the sample mean is 4 for x. And the standard deviation for x is 2.44949. Okay, and then for y, we get a sample mean of 10 and a sample standard deviation of 5.612486. Okay, so now that we have that, now the next step is to now determine the x minus x bar over the standard deviation of x, and y, the data value minus the sample mean of y divided by the sample mean of the y values for each observation. So we're going to use step 2 and step 3 and step 4 and then create columns to be able to determine our linear correlation coefficient. So down here you will now notice that we have our table. Okay, now what is the sample mean for x? Well, our sample mean for x is going to be 4. Okay, so we know that we have 4 for our sample mean. Okay, now we're going to create these columns. So the first column again is for the sample standard deviation for x. Well, the sample standard deviation for x is 2.4494897. So we're going to put in 2.44949 in for all the values for the sample standard deviation for x. Okay, now what we're going to do is we're going to take each data value of x and we're going to subtract the sample mean and then divide it by the sample standard deviation. So please follow along here. We're going to see the following. So we have the data value of x, which is 1, and then we're going to subtract the sample mean of x, which is 4, and then divide it by the sample standard deviation of 2.44949. And as you can see here, it's going to give us the data value of negative 1.2247. Okay, and then the next, okay, we're going to do the next one. So now we know that the data value is 3, and then we're going to subtract the sample mean of 4, and then we're going to divide it by the sample standard deviation to give us the value of negative 0.4083. Likewise, we're going to take the next data value, which is 3, and then we're going to subtract the sample mean of 4, divided by the sample standard deviation of 2.44949 to give us negative 0.4083. Next data value is 6, and then we're going to subtract the sample mean of 4, and then divide that by 2.44949 to give us 0.8165. Our last data value of x is 7. We're going to subtract the sample mean of 4 and then divide it by the sample standard deviation of 2.44949 to give us the value of 1.2247. Okay, and so now that gives us step 2. So we figured out the first part of step 2. Now we need to figure out the second part of step 2 using the data values for y, the sample mean for y, and the sample standard deviation of y. So we're going to put in that information. So here you look for the sample mean of y. We found it to be 10. So we're going to put in 10 into the column. And then the sample standard deviation for y is 5.612486. So we're putting that for each individual y. And then now what we're going to do is now we're going to solve for the following. So now we're going to use the data values for y. So let's take a look at the data value for y. So the data value for y is 18. So we're going to take 18. And then what we're going to do is we're now going to subtract the sample mean for y, which is 10. And then we're going to divide it by the standard deviation of 5.612486 to give us the following, 1.4254. Let's do that again. We have our data value of 13 for y, and then we're going to subtract the sample mean of 10, dividing it by the standard deviation of 5.612486 to give us 0.5345. Next, we're going to take the data value of 9, and then we are going to subtract the sample mean of 10, divided by the standard deviation of y, which is 5.612486, to give us negative 0.1787. Again, we're going to take our value for y, which is 6, and then we're going to subtract the sample mean for y, which is 10, dividing it by the sample standard deviation of y, which is 5.61246, to give us negative 0.7157. And then lastly, we're going to take the last data value of y, which is 4, and then we're going to subtract the sample standard deviation of y, which is 10, and then we're going to divide that by the sample standard deviation for y to give us the result of negative 1.0690. So now we've completed step 2 by finding the values for each of those. Now in step 3, we need to take the value that we got in this column and multiply it by the value that we get for this column here. So the last column, we're going to take both of those values. So we take negative 1.2247, and then we're going to multiply it by 1.4254 to get negative 1.7457. Okay, next, we're going to take the value of negative 0.483, and then we're going to multiply that by 0.5345 to get negative 0.2182. Okay, next we're going to take negative 0.4083, multiply it by negative 0.1782 to get 0.0727. Next, we're going to take 0.8165, multiply that by negative 0.7127 to get negative 0.5819. And then the last one, we're going to take 1.2247, and then we're going to multiply that by negative 1.0690 to get negative 1.3093. Then we want to find the total. Okay, so the total is to add these all up. So we're going to add this with this number, and this number with this number, and this number, to get a total of negative 3.7824. And now from here, we're now going to use the formula. So now, once we found this, now we're going to substitute in the formula over here. So we're going to add the entries in column 9, which we did, and substitute that value into the numerator. So the numerator, R is going to equal the numerator. The numerator is negative 3.7824. Now, what does n represent? Well, n represents the number of values that we have. So we have 1, 2, 3, 4, 5. So that means that from our data set, we know that the value of n is equal to 5. So that means we're going to take n is equal to 5, there's 5, and then minus 1. So if we take this negative, and let's go ahead and do that here, we have our negative 3.7824. We're going to divide that by 5 minus 1, which is 4, which gives us, rounding this to 3 decimal places, negative 0.946. So we will agree to round the correlation coefficient to 3 decimal places, and the correlation coefficient suggests a strong negative association between the two variables. Okay, go back to the graph. Well, you can see here that it looks like it's a strong, and it's going downward, so you can see what the line looks like. Okay, so if we look at the scatter diagram of the data below here to the left, in the scatter diagram, the mean of the x and the mean of the y is drawn. So there's the mean of the x and the y. Notice that below average values of x, which are to the left here, okay, are associated, notice that below average values of x are associated with above average values of y, and above average values of x are associated with below average values of y. Now compare the signs of the entries in columns 5 and 8. So columns 5 is the following. So here are column 5, okay, and then column 8 are the values in column 8. Okay, now notice that the values in column 5 correspond to the positive values in column 8. So the negative values in column 5, so here's a negative times a positive, which makes that a negative. A negative times a negative here is going to be, well, this negative times this positive is negative. This negative times this negative makes that positive. And then the positive values in column 5 times that negative makes that negative. And the same thing here, the positive values times the negative values gives us negative. Now recall that the product of the negative and positive numbers is negative. So the entries in column 9 are negative except for the third row. This is why the linear correlation coefficient is negative, is because when you add all these numbers up, you're going to get a negative value. Okay, now that gives us our result and explains this to you why those numbers are the way they are. Now for this next example, we want to determine the linear correlation coefficient using technology. We're going to use a statistical spreadsheet or a graphing calculator with advanced statistical features to determine the linear correlation coefficient between club head speed and distance from the table from the data in table 1, and then we're going to interpret the linear correlation coefficient. Okay, so we can either enter this information by hand or we can pull this in from StatCrunch. So I'm going to pull this data in from StatCrunch. Okay, and I do want to make a little correction here. The title of this column should be distance. So I'm going to make sure that this says distance at the top. Okay, and then what we want to do is we're going to use these instructions to determine the linear correlation coefficient. So again, if necessary, we enter the explanatory variable in column 1, and then the response variable in column 2, which we already have, and then we're going to name each column variable, which it is. And then we're going to select stat, highlight summary stats, and then select correlation. So we're going to go to stat, summary stats, and then highlight correlation. Okay, and then we're going to click on the variables whose correlation you want to determine, and then you're going to click compute. Okay, so we're going to click on the club head and the distance. Okay, and we want to find out what is the correlation. So when we put them together, we're going to get the following. So here is our data. Okay, so the correlation coefficient between the two variables, if we round it to 3 decimal places, you notice here, is going to be 0.939. This value, which is close to 1, taken together with the appearance of the scatter diagram, suggests that there is a strong positive association between the club head and speed distance. Let's take a look at the scatter diagram for this. Okay, so we're going to go to graph, we're going to select scatter diagram, we got club head for the x variable, the y variable is distance. Okay, we want our points, and then we're going to select compute, and then let's go ahead and copy this scatter diagram. Okay, so what we've done is we can see that this 0.939 resembles a strong positive association between club head speed and distance. So because the linear correlation coefficient is positive, above average values of x, club head speed, are associated with above average values of y, driving distance, and below average values of x are associated with below average values of y.